So trig integral. That's the reason why I want you to review the trig identities. Let's pay attention here. Let's pay attention here. What is sine square plus cosine square?
One.
Okay.
Oh no, wait, two.
That's
Now I need
You want to be
practice further
struggling?
before- No, I want to. Yeah, yeah, exactly.
Sine square equal to 1 minus cosine square, and cosine square equal to 1 minus sine square, right? Okay, what else? What is the secant square minus tangent square? Secant square minus tangent square is also 1. Okay, so from here, secant square equal to 1 plus tangent square, and tangent square equal to you move the negative tangent over here better because it become positive, and move the one over here become negative. Whenever you move whenever you move around the side, the sign going to change. Yeah. So tangent square equal to secant square minus 1. You move the negative over here to become positive, right? And then you move the 1 over here, it's become negative. So tangent square equal to secant square minus 1. Okay, from here. You also have cosecant and cotangent, same thing. Minus cotangent square is 1. So cosecant square equal to 1 plus cotangent square. And cotangent square equal to cosecant, very good, minus 1. You got it. Okay. Sine of 2 theta equal to double angle equal to 2 sine theta cosine theta. Okay, this is very popular. You should memorize this. Not just for this trick shot, but a lot of concept we're using this. How about cosine? Cosine square minus sine square. Very good, very good. Another thing. How do you do that? So from here you can also get what? Think about you changing one cosine square by, you can replace this, right? Cosine square is 1 minus sine square, right? I replace the cosine square by 1 minus sine square. Let's see what happened. Okay, you're gonna have 1 minus sine square minus sine square. So what is this? 1 minus 2 sine square. So basically you need to memorize this, and from there you can get the second one. You don't need to memorize a lot. Okay, so that means you have 1 minus 2 sine square. Now what about I don't replace the cosine square, but I replace the sine square? Can you try that? If you memorize the formula, then that's it. But if you don't memorize the formula, that's how you do it. You replace the sine square by 1 minus cosine square. Okay, so let's see what happened.
This marker sucks. Here, try this one.
Minus 1 minus cosine square. Okay, so cosine square minus 1 plus cosine square, because of negative, right? So that's good. And that equal to 2 cosine square minus 1. Maybe I need the assistant. Huh? Hello? Okay, yeah. Yeah. Isabel, go to office. Okay. So equal to 2 cosine square minus 1. Okay. It's just formula. That's what we just did the quiz. Now half angle. How about sine square?
Oh, I know this one. 2 sine. I mean 1/2.
1/2.
1 minus cosine squared times squared.
Yeah. Exactly the same. Exactly the same. It's just the different sign. Think about the sine and the cosine are two different things. right? Sine, cosine, two different things, so they're going to be minus. But
So there was just plus.
yeah, the other one is just plus. Okay, so exactly the same. It's just different the sign. So how do I remember this? I just remember, oh, sine and cosine, different thing, minus. Same thing, cosine and cosine plus. But you need to memorize the structure though. 1/2, 1 minus. Or you can write 1 minus cosine 2x over 2. Same thing. Yeah? So far so good?
Yeah.
Yes. Question?
Like on the quiz you just gave us right now, I put data instead of the two letters.
Oh, x and theta is same thing. It's just a letter. I can also put like sine square irma equal to 1/2, 1 minus cosine 2 irma, right? Remember, they just represent something. They just represent some letter. Yeah. Cosine square labu equal to 1/2, 1 plus 2, 1 plus cosine 2 labu. Same thing. Labubu. What is integral of cosine x dx? How do we handle this?
Oh, I is in
Equal to? Huh? What? 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 You don't think too complicated. Okay, don't think too complicated. It's just integral cosine. Uh-huh. So what's it good? No?
Wait, I knew that.
Okay. How about cosine square?
Oh, there you go.
That's right.
So you want to
You're gonna lose it. You remember map, they're all connected. If you're missing this one, next one gonna be hard. So you always need to be here, okay? Mentally and physically. Cosine square. How do you handle this?
oh wait. One minus sine x there.
You break them up. What next then?
One minus sine.
If you're gonna use it for the cosine, the derivative of cosine is negative sign, but there's no sign here for you to cancel out. Kayla? We use the formula. That's why the formula is right there, right? Cosine square, right here. Why the formula gonna be helpful? Because you don't bring down the power, right? Square become no square. So that's what you can do. So this integral of 1/2 1 plus cosine of 2x dx. What next? So you're gonna bring the 1/2 out outside. Usually when you see that's formula here, right? 1/2 1 plus cosine 2x, right? You see following? It's just a blood formula, okay? Now 1/2, you can take out a 1/2 or you can distribute either way. I'm gonna put 1/2 to the front and then 1 plus cosine 2x dx. Okay. What is the integral of 1? X. Very good. What is the integral of cosine 2x?
2x divided by 2.
Sine of the integral of cosine sine, right? So integral of cosine is still sine, but this is cosine 2x. So integral of cosine 2x is sine of 2x. But here again, this is the dx, this is 2x. Oh, they're not the same. That means there must be a chain rule. And then, so derivative of 2x is, do you multiply by 2 or you divide by 2? Why will we divide?
I got no clue, but that's just what you said.
Because we integral. You only multiply when they are derivative. Okay? Okay, so the answer is 1 over 2x plus 1 over 4 or sine 2x divided by 4. Sine 2x divided by 4. Let's see. Yeah? Nothing fancy yet. Nothing fancy yet. Yeah. Yes.
The dividing by 2 part.
Here? Here? Here?
Sine 2x divided by 2.
Here? This one? Put 1/2.
Write down like it's a
Oh, the reason? Yes. Okay, sure. All right, thank you for letting me know that. Yeah.
I realized like you write there was like I was like,
Bro, nah, that was just bad.
Because it's a marker. Let me try again.
No.
Hey, Brad, it's your turn.
No.
oh my god.
Wait, $5 I'll make it back into the
Go. Put it right here.
Bro, why did you put it right in front of me?
Yeah? Is it better? Yeah. Okay. Remember that is still warm up, right? Okay, today. Integral of cosine cube.
Oh, I know this one.
Ooh, I saw the video on it.
Oh, me. Why is there for? Mr.
1/2 times 2.
Oh.
No. Any question? No silly question. Okay? 1/2 times 2.
Wait, mister, I have a question.
Yes.
For the number 2 stuff, for sine x, couldn't you just use like a formula here, like 1 minus 2 sine, or no?
If this is the sine square, if that is the sine square, then you're gonna using you're using this. Is that what your question is? From here?
Yeah.
Yeah, I just applied this one.
Uh-huh.
So cosine square is 1/2, 1 plus cosine 2x from here. Formula. Okay? And from here I took out the 1/2 constant, and then I take integral of inside.
Okay.
Every time you see the number, it's better to put
So
outside.
you just took the integral
Of
of
1.
cosine 2x?
Integral of 1. Integral of cosine 2x.
Okay.
Okay? Integral of 1 is x. Integral of cosine is sine.
Yes.
But because this is 2x, that means you need to divide by the derivative of 2x, the chain rule. Divided by 2.
I got it.
And then distribute 1/2 back. So 1/2 times x is 1/2 x.
Okay.
1/2 times this is 2 times 2 is 4.
Okay, I got
Yeah?
it. Thank you.
Yes.
So you know how you're getting the integral of cosine, right?
Mm-hmm.
So why didn't you like use the other formula that says cosine to theta equals to theta minus?
Because we only do that if you don't know how to check the integral of cosine 2x. But if you know how to do that, you don't want to make it complicated, right? Why are we using this formula? Because we don't know how to check the integral of cosine square. That's why we use formula. But this integral of cosine 2x, we know it. So you don't want to use formula. Okay? Good question. All right. Any other question? All right. How do we handle this? What do you think?
We
Break
take
it
out
down.
a cosine and then plug in.
Oh, very good. Someone watch the video.
I watched it.
Very good.
I said it, mister.
Yeah. So I know who watched it. So the strategy to handle something like this, do you see that just go one more power? But did you see that all different method? First one straightforward. Second one needs to apply formula. Third one, you need to do something. You need to break them down. Okay. And the strategy is you're gonna break them into just one away. So it's odd. Then you're gonna spread them into one cosine and one square. If it is 7, how do you break it? That's right. Cosine to the power 6 and cosine. You get one out. Just get one out to make this one become even. Okay? Why you want to make them even? Because you can use the formula, right? Because when they're even, you can use the number 2. But if they odd, you don't know the formula for odd, but we can take one out. But how do they work? Let's do it. So you're gonna have cosine square times cosine dx. Yeah? Now what next?
We apply formula. We change the cosine squared x to what it equals.
Which formula are you going to use? Are you going to use the same formula over here?
No, because you want to cancel.
Because if you do that, you're going to have cosine 2x times cosine x. And you don't know how to do that yet. Okay? So here is the strategy.
You use the 1 minus sine.
Let u equal to.
Yeah.
So basically the trig integral using the u sub. Okay. The foundation beneath underline of trig integral is u sub. U sub is the easiest one, is it? Comparing to integration by part and partial fraction, u sub is the easiest one, right? Now what you're gonna do? What you're gonna let u equal to though? If you let m equal to cosine, don't write yet, okay? If you let m equal to cosine, then du equal to, right? Do you see anything sign though? Do you think any sign here? Right. So you now, okay. You want to change them first? If we can change them first. The formula you want to use for, because oh no, but don't do that. I want to lead to your thinking. Let u equal to sine x. Du equal to cosine x dx. Why do I let it sine x? Because I can't. Do you see this happen? Yeah. But if you use u to be the cosine when you take the derivative, you need to have sine over here. But there's no sine over here. But if you let u equal to sine, du, derivative of sine is cosine, then you see that here? You can cancel them out, right? So dx equal to du over cosine x. So later we can cancel the cosine. Now, that's what we do next. I know in your mind you all have question. Where the sine then?
Thank you. Sorry.
Where the sign then? I don't already know it. Where the sign? If you watch the video, you know this. Brad, where the sign?
I don't know.
Okay. Oh, I'm not telling you, mister. Yes. Cosine square. Cosine square. This formula, very important. You need to know this. This formula, oh no, not this one. This formula and this formula, these three are very important. You will see all the time with the calculus BC, all the time. These three, yeah.
So how do you know which one to use? Because for the other problem we use the half angle one, and for this one we're using the Pythagorean. So how do you know which one to use? Like at what time?
This one they don't have anything else. They just have one term. Then you're gonna use this one. But this one, because if you try to using the okay, let's write down here. Okay, if you try this one to be 1 plus cosine 2x over 2 times cosine x. If you distribute this, you're gonna have cosine 2x cosine x. Later you have this term and you don't know how to do this. It's more complicated. Yeah, you can try. If you plug it in, you see something you stuck, that means that's not gonna work. Then you can try the other one. Yeah, make sense? Okay, so not work here. Question?
Where's the a squared plus x squared? Is that it?
That trig sub? No, this trig sub. No, this is trig integral. Trig substitution is different one. It's gonna be we're gonna learn it tomorrow. It's more complicated. That's why I'm gonna start with this one first. Okay. Question? Any question? Yes.
Wait, can you move like the screen a little like that?
Now this one is not working. This is from the to answer question from Brad. So don't worry about this. Okay.
Also, so what you did with the sign was switch with like the formula at the top, right?
We're gonna use this formula 1 minus
Yeah,
sine
so
square.
the sign
Okay.
And then, like, okay.
Yeah. Okay, we're gonna do that one then. So this one is actually equal to 1 minus sine square cosine x dx. Now do you see the sign happen?
But it has a square.
U is sine. What is sine square then?
U squared.
U square. Yeah. So let's substitute it. So we're gonna have 1 minus what? 1 minus what? 1 minus u square. Now cosine x, just keep them the same. You will see that cosine x dx actually equal to the u. Okay. But I'm gonna write the way we have learned, we have been doing. So dx equal to du. So du over cosine x, and you can cancel this. You have 1 minus u square du. Oh, now this is very simple, right? What is integral of 1? U. Now it's u, not x. Now it's u. What is the integral of u square? U cubed divided by 3 plus c. Is that your answer? No, you need to replace back to the x. So u is sine x, so sine x minus sine x cubed divided by 3 plus c. That's it. That's basically the main concept, the main strategy for the trig integral. Yeah. From here. So I replace the cosine square. I replace the cosine square to be 1 minus sine square. Okay, from the Pythagorean identities. From here, what do we want to do? I'm gonna let u equal to sine x. So sine square is u square, right? So I should replace it. 1 minus sine square. Sine square is u square, so I have u square. Du from here, dx is du over cosine x right here. Right, so I cancel out the cosine x. Then I have left just 1 minus u square. Yeah, that's the concept. That's the strategy. Yeah. And then you replace the u by sine. Oh, the integral. This is the integral. No integral, right? Integral of 1 is u. Integral of u square is u cubed over 3. Because they are u right now. After you got u, this is the u, du already. Du. Yeah? You got this? Good. What about, let's increase the power. Increase the power. What about cosine 4?
You can pay for that.
Answer we had before times 2. Oh no, we just multiplied this times 4.
Which one? So what method you're gonna use? You're gonna use u sub? You're gonna use formula or what?
Wait, no. I'm happy.
How do you handle this? Huh? You break them apart? Like break cosine what? How do you break it? Cosine square and square, right? Do you need to break them to like cosine cube and 1 and cosine 1? No, right? The reason we break this one because we want them to be even power, right? But this one is already even power. Either this formula or this formula, right? But think about this. If you change the cosine 4 to be 1 minus sine square, they still have power. They still have the power. You still don't know how to do this. So from here, you're gonna using this formula, okay? The half angle formula. So that we're gonna do what Isabel just said. So cosine square. Do you agree?
Yes.
Right? What is cosine square? Is that the same thing as the example number 2? It's exactly the same thing, but now it's going to be square. That's it. So cosine square is 1/2. 1/2. 1 plus cosine 2x. Everything square. So what's good?
So we take out the half.
Is that half? Yeah. So we're gonna take out the half out. Yeah. No. It's not. It's not 1/2. What is that then? Is it 1/2? It's 1/4. Don't make that mistake. Okay. That's the last student make the mistake anyway, because it's square. Everything here is a square, so everything here needs to be square. So 1/2 square is 1/4. So don't forget that. Okay, 1/4 and 1 plus cosine 2x squared. How did you check the integral of this though?
Oh, you need a foil.
Huh?
Do you have to take the
You distribute the power too? So 1 square and cosine square?
do you have to
Yes. You need to expand them. Okay, you need to expand them. Don't just do this one will be 2 plus 1 and power 3 and divided by 3. No, because this is the whole thing here, the whole function here. You need to expand them, like Valerie just said. What is it equal to though? You remember a plus b square? A square plus 2ab plus b square. You need to you also need to memorize this, okay? A square plus 2ab plus b square. Yeah? Or you can do FOIL, but FOIL longer. You own calculus BC ready. Don't use FOIL. FOIL for like algebra 1, algebra 2. You should memorize this formula, okay? So 1 plus 2 times. Yeah, no, the video do the FOIL because I think, I don't know. You want to be very detailed though.
I like his videos, they're really good.
He wants to be terrible. Yeah.
Yes,
I like
yes.
No, because that's why I send you that video. Very detailed and slow and build up from easy to hard, right?
Oh, B. Oh, my bad. I did the. Oh, my bad.
So far so good? Yes?
Oh.
Yeah? Okay, now just do integral 1 by 1. What is integral of 1?
X.
X. What is integral of 2 cosine 2x? So 2 you're gonna put in front, right? 2 just a number. You're gonna put 2. So don't worry about the 2. 2 just a number. Now what is integral of 2x? Cosine 2x. We did it already. Integral cosine 2x is sine 2x over 2. Very good. There's a chain rule here, so over 2. And later you see that 2 and 2 they cancel out. Okay? Where did 2 come from? This 2 come from here. Where did 2 come from? This 2 come from the integral, and then you get the chain rule. Okay? Don't be confused. What is the integral of cosine square 2x?
Great question. So since we have a square, we have to add plus 1. Or
You add plus 1. Oh, if you do that, then we're gonna do plus 1 here too, right? But can we add 1 to here? No. What did we do with the square?
we turned it into
Double angle, a half angle, right? So square here, same thing, half angle. That's why I put you a quiz 2 times, because you need to memorize that half angle, okay? So you're gonna have what? Half angle, 1/2 of what? 1 plus cosine.
2x.
Is that 2x?
Because we still have a 2 in there.
4x.
Oh, the square.
Cosine square of x is 2x, but this is cosine of 2x. You're gonna have 4x, right?
Yeah. You distribute
Yeah?
the square to everything.
So far so good. Yes, you still following? Stop me anytime, ask me, okay? Also remind me to maybe slower or speak slower or wait for you or something, okay? No, I just we go with here. We're gonna continue though, okay? Yeah. That's right. That's right. That's right. It's still the integral for that part. So we done the integral of the first two. Now we need to integral of this. Now this one we just rewrote it to become 1 plus cosine 4x because 2 times 2x is 4x. It's still 1/2. Okay. And remember 1/4 is for everything. So you need to have like a big parenthesis here. To remember 1/4 is distribute everything. So you see, it's very tempting, very easy to make a mistake here. You will forget to multiply 1/4 to this thing because the whole thing 1/4 multiply for everything. Okay, so 1/4 here, everything. That's why I have parenthesis here, parenthesis here. One parenthesis for this one parenthesis for this one, but one parenthesis for the whole thing with the 1/4. Okay. Now 1, 4 here, I have x plus sine 2x now, plus, what is the integral of 1 half? Oh, x over 2, right? Same thing, right? 1 half x, x over 2. You know, same thing, right? Yeah, okay. Plus, integral of 1 half cosine 4x. What is integral of cosine 4x? You just did the integral of cosine 2x already. Same thing for this, huh? Cosine. Okay, integral of cosine 4x is sine. Okay, sine 4x over 4. Very good. Chain rule. But don't forget, we still have 1 half everything, so this is time 2, right? Yeah? Okay, 2 is from here. And then 4 from chain rule. So 2 is from here. Okay? Yeah? Just so you know where the 2 come from. Okay? So what's it good? Yeah. Yeah, 1 half times 1 times 4. This is multiply. 2 times 4. Integral of 1 is x. Right? And you have 1 half times x. It's x over 2. Yeah. I just distribute 1 half in everything. Yes. Okay? Good so far? Be careful of the number, okay? That's why if they put on a multiple choice, if you mess up the number, they can make the wrong answer and you look at the same as your answer. That means they can be very tricky. Yeah.
Now we have to distribute the 1.
You need to distribute the 1, 4. That's the last thing. Why didn't I put the parenthesis include a c? Because c doesn't matter. It's still a number. Okay. So to make it less complicated, I just put a c outside. Get to the number. Okay. Now distribute of 1, 4 everything. That's your final answer. So your answer is, oh, look at this. X and x is over 2. You can combine them though. Combine that term. X plus x over 2 is? Huh?
Oh, wait.
X plus x over 2? X square? X plus x over 2. Is x?
No.
I need to lie down. Okay. Smiley face plus 1 half smiley face. How many smiley face do we have? Oh, that creepy face though. 1 and 1 half. But give me a proper fraction. Improper fraction. Fraction. 3 over 2 smiley face, right? So x plus x over 2. 3x over 2.
Yeah, just kick us out the class, Mr. Just kick us out.
Over 8. What the answer then? 3x over 8 plus sine 2x over plus sine 4x over 32. I just distribute 1, 4. Yeah. Uh-huh. From here, x and x over 2 is 3x over 2, right? You add them. 1 plus 1 half is 3 half, right? So we have 3x over 2. This one is just copy that. This one is just 2 times 4 is 8. And now I'm going to distribute 1, 4 everything. That means I multiply the bottom by 4. So 2 times 4, 8. 4 times 8, 32. Yeah? Yes. We're almost done though. Okay. 5 minutes. You see that? You just increase the power by 1. You see how complicated it is? Okay, try by yourself. I think we have 6 minutes. You can try by yourself.
Mister, I can do this in 6 minutes.
No, but Different method for this one though. Let's increase to the power 5. How do you break it?
A squared plus 2ab plus b.
Cosine,
Oh, I thought he meant
cosine 4, right? Cosine 4 or cosine 2 too. This should be more precise. Cosine square and square, and then cosine x. Then don't use a half angle because half angle when you only have this, but this one you have this extra. Utilize this. It makes your life easier because u sub is always u sub is shorter than this, right? When you're using the u sub, look at this one, only a couple lines. But when you're using half angle, it's very long. Only when you don't have this, you have this. When it's already even. If you is odd, if you break them using the u sub, okay? But u equal to what? U equal to sine or cosine? Sine, because the derivative of sine is cosine. Okay? So you're gonna let u equal to sine. Du equal to cosine x dx. And then how do you change this one? You're gonna using the, is it half angle?
No.
No, you're gonna using 1 minus sine square.
Sine square.
Everything square. Okay? Cosine x dx actually equal to du. So I'm gonna just put du. Okay?
If you
Cosine du.
Because if you do half angle, you're gonna get another cosine.
Now 1 minus sine square, that means 1 minus u square, right? Oh, the bell is going to ring soon.
We have 1 minute.
I know.
Oh, whoa.
That's it. You see that? It's going to be u minus 2u cubed over 3 plus u5 over 5 plus c. And that's going to be sine x minus sine cube divided by 3.
I got it. Well, I was on track on getting
That's it.
because I ran out of space, but
Okay, let's go. Do you remember how we handle the cosine of when you see the odd power?
oh yeah, we take one out.
Yes. So odd power, I think last period I talked with some of you. This is very good thing. Odd power. Okay, let's write a strategy. First, whenever you see the odd power, that's a good thing because odd power you can use u sub. Okay, and u sub is faster. U sub is the best one. Save one, or how do you say it? Break one, separate. Okay, separate one term to make it even. And convert it using sine square plus cosine square is 1. Okay, for example, cosine, how about sine? Separate one term to make it even and convert it using sine square plus cosine square is 1. So if you see the odd power, that's actually a very good thing. Okay, because odd power, that means you can use u sub. If you don't have the odd power, that means you need to using the half angle, right? And that's you remember it's maybe more complicated. Okay, so if you see the odd power here, that's a good sign. What you gonna do? You're gonna separate them. So I'm gonna separate to be sine what? Sine 4 and just sine power 1. Okay. Now how do you do u sub? U sub. Let's u equal to cosine or sine? Cosine. Very good. Why you're like, oh hey, I don't see any cosine here. So why do I using the cosine for the u? That's right, because the derivative of cosine is sine, right? Yeah, negative sign. But you see the sign happen. So u equal to cosine then du equal to negative sine x dx. So you see that the sine x here and the sine x here happen. So that's how you cancel it. Okay. You can do like what we have been doing to be careful. So du equal to dx equal to. But if you can see, sine x dx, so that's mean the whole thing here equal to negative du. That's fine too. That's faster. But maybe just be careful. You can write dx equal to du over sine x. Oh, so it's good to start with the Buddhism story before lesson, huh? Now you all pay attention. Different. Every day 5 minutes we're gonna do meditation, Buddhist. Yeah, okay, okay. What we're gonna do with a sine 4? We only break it, right? Now here, separate one term to make it even. Did we make it even already? Yes, right? Now convert it using sine square plus cosine square is 1. So sine 4, how do you convert it?
You make it cosine.
Sine square is actually equal to 1 minus cosine square, right?
Oh my god.
Yeah? Oh, you know it. That's good. You should keep that in your mind. Right. Always remember this, okay? It's very popular. Yeah. Yes, that's right. Because this is the 4, right? So I need it one to be 4. So what I'm going to do? I'm going to square everything. So actually sine 4 will be equal to 1 minus cosine square and square outside. Yeah? So what's good? Your step is easy. So if you see the odd power, that's a good sign. And now sine x dx, you can write negative du, but if you want to be careful, you can just go one by one. Okay, I still have the sine x. And now the dx become negative du over sine x. So negative du over sine x. Do you see the sine cancel out? That's the reason why we put u equal to cosine. Okay? Sine gone. Now what is this equal to though? U square. U is cosine. U square, cosine square is u square. So now everything is normal x, right? Yeah. That's right. 1 minus u square and square du. Is it correct so far?
Wait, why is it 1 minus 2?
That's right. This is a common mistake, okay? Don't forget this negative, this sign. It can change everything. One minor wrong is screw everything. That's math. Okay, that's very, very cruel. Negative. I just take the negative outside. Okay. Did you raise your hand, Elma? You have a question? Yeah. Which one?
I understand like the whole process and everything. It's just like at the very beginning. No, like where the U is. The U. Okay. No, yeah. Right there. Okay, so right there, you put it as cosine. And I know why, like I understand why. Because, but you use the formula up there, right? The sine x plus cosine x plus equals 1, right? Okay. If you
Right.
were using that one and like you were making it equal to sine x, why is the u not cosine x minus 1?
Why u is not cosine x minus 1?
No? Okay, I'm asking the definition.
Because if you do that, this is going to be not the u. You will make more complicated because now cosine square is not u anymore. But cosine square become u plus 1 square. And it's just more complicated. And you don't need 1. You don't need the 1. Okay, you don't need the 1. You're just using the cosine. This one is not for this. Remember, cosine is for this one. And this formula is for this one. Okay, this formula you're using for this. This one is for this. Your cosine is for this. To handle this one. Kind of. I hope I answer your question. Okay. All right. Now this one is easy, right? What you gonna do? What you gonna do with this? You expand it, right? You expand it. What is that equal to? 1 minus. Very good. 2u squared plus u4. Awesome. Okay. And now you can take the integral of each, right? What is it? Integral of 1.
You.
Is that good? Is that okay? Is that good? Right? Integral of 1 is u. Very good. Integral of 2u squared. 2u cubed over 3. 3, right? And plus u over 5. That's 3. It's 3. Plus c.
No, you put 3 on the U.
He did it right.
Oh, this is 5. This is 5. Okay. And now you need to change back to the x. What is the u? U equal to cosine x. So I need to change everything back to cosine. Okay. Oh yeah. See, even me, it might be stuck. See, so it's very tricky. You need to be careful. So I need to change this one to net. So minus cosine plus 2 cosine over 3 minus cosine 5 over 5 plus c. Yeah? Good caught.
Oh wait, you already changed it. No, you already converted.
I have the negative outside here now. And now I distribute it. That's why I have negative. I distribute it, I have positive. I distribute negative, I have negative. The constant, you don't worry about it, okay?
It's because I was still on the U, and then you already converted it back to.
Oh yeah, I'll convert to x. Okay. So was it good? Good. This is the example number 6, right? Okay, so example number 6. Let's go example number 7. Can you try it? Try it by yourself. Try it. You only need to break down. You only need to break down the odd power.
Wait,
You don't need to break down the even power.
So we break down the cosine and make cosine u to make it negative sign and get rid of the extra sign, or something like that.
So u equal to?
Cosine.
That's right.
Wait, wouldn't you just do the thing where you did a minus b squared?
Oh, it's after, bro.
No, for the
Let me try
cosine.
this.
You focus on the odd power. Okay?
Because we still have an extra cosine here.
Look at this one. Let me give you a hint.
I mean, we still have a sign.
Which power is odd? Sine or cosine? Sine. And then you let u equal to cosine. Okay? Now look at this one. Which power is odd? It's sine. Then you let u equal to cosine. Opposite. Okay? Opposite. Just continue. Okay? I just write it. I think you all got there. I'm gonna break this one to sine square and sine. How many you get the first step? Good. Okay. Then I'm gonna let u equal to what? Cosine. Remember the odd power is sine, then you let u equal to cosine, opposite. Okay? Cosine x dx. Du is negative sine x dx. Dx is du over sine x and negative. Okay? Now this become
Why does you have a DX?
oh, something wrong with me today. Sine square. I don't know yet. Sine, I know that sine x and dx will be cancelled from here. Cosine for x. What is cosine for x?
U4.
U4, right? Yeah. U is cosine x. So cosine 4 is the U4. But I don't know about sine square. Then I need to use in the formula for sine square, which is 1 minus. Very good. 1 minus cosine. Because u is cosine, I want to change everything here to cosine, except the sine. Because sine is here, will be cancelled out. Okay?
You're something. You're a real hoot in the hall.
Don't forget the negative. from here. Okay. Oh, not yet, not yet. From next step. Yeah, next step. That's right. That's right. That's right.
Sine x is not canceled.
Oh, what is the cosine x though? Cosine square x is
U squared.
u square. You got it. You got it. And then dx, I'm gonna changing.
That's what it does.
Actually, if you can see sine x dx is negative du. If you can see it, you don't need to this step. I want you to do this. It's just because I want you to be detailed and be careful. Like it just prevent making a mistake. But if you think you're good, you're confident, you can just see that sine x dx is here. Replace the whole thing here by negative du. Okay. Do that only when you're confident. If you're not confident, just do this. Okay, then do this one. Okay, then do this one. I just write everything again. Sine x, and then dx is negative du over sine x. That's why this one more careful. And then you cancel the sine x. I put the negative out. Oh, this one look good, huh? Look like calligraphy. Now what you gonna do? You distribute. So u4 minus u6 du. And now it's very easy, right? Equal negative u5 over 5 plus u7 over 7 plus c. So cosine 5 over 5 cosine 7. Is that correct? Did I do something wrong? Is that correct? Is it correct? How many of you got this? Good. And I saw a lot of you on the way there. Okay? But just because we didn't have enough time.
So when we're distributing the U4 into the U2, we don't multiply.
Multiply the power to become U8.
The power.
Good question. Good question. Good question.
Extra fundamental.
That's the ramp of fundamental. When you see two power next to each other, you multiply. But they're not each other. They're not next to each other like this. You're gonna add. I know because you didn't take my hand, so it's fine. It's fine. Yeah.
Wait, mister, but you looked at my answer and you said I was right, so that's how.
Oh, I didn't see it then. Oh, yeah. I distribute U4. U4 times 1 is U4. U4 times U2 is U6. Yeah? That's why I just explained to Brad here. If you multiply them, you add the power. So this is U6. But if you see the power outside, 2 times 4 is 8. That's different. Okay? That's two different things, okay? And then you got this. Yeah? And then I just take the integral. U4 is U5 over 5. U6 is U7 over 7. Distribute a negative. Distribute a negative. I have negative here. Negative become positive. And then replace the U by cosine. Back. Yeah? You got this, right?
Mister, this is still simple. Is this trig integral?
It's still trig integral. I think you're good, right? Can we move on? I think you're good with this, okay?
You want to try one? Wait, mister, can you give us one of the integral of doom?
No.
Of what?
The integral of doom?
Mister, don't listen.
What do?
Like a super hard one to see.
Oh,
if
super
we're,
hard.
like,
It's
smart
okay.
enough.
Keep that confident. I don't want you to lose it.
Okay.
Called, oh.
It's 6. Power theta? How does it make sense?
That's why I was like,
I need to meditate more. Ooh, now they're both even.
And then on the day we have tests, Mr. Vardy asked me, Mr. Lee, why all your students meditate? They didn't do anything.
We leave the papers blank. We just write on the paper. I know Buddha will write.
No. Yes. All right. How do we handle this? Are we going to separate them? Oh, good. Why not?
Because you're even.
Because they're both even. There's no odd. You only break them when they are odd because you want even happen. This one even already happened. But this is not as easy as the use up. Then this one you need using the half angle formula. Okay.
First half angle.
Wait, what?
We did it over here.
Why do we use half angle? Because they're multiplying together?
We did it here.
What?
We did it on the but we converted
Oh, low battery. It's okay.
we converted it to be square.
So I have to see the lesson. Wow. Okay, what we gonna do with this?
Mister, do you
Huh? Okay. Okay. Let's finish this one. With trig up, you still have one more thing, the secant and tangent. Okay. And then we're gonna just go briefly. My goal is to get briefly the trig up. Okay. Now here. Do you see any odd power? No. Then you're not gonna using use up. But you see two things happen. You see sine and cosine. Can we make it like easier for us? Like change them all to become just one thing? Like either all the sine or either all the cosine? Can we do that? Like how?
Isn't it like
we
one
changed the
minus-
power?
Which formula we're gonna use? Not half and go yet. We'll be using that, but not
Is
yet.
it the one where
You want to
get
change them into the same thing first, same trick.
rid- Is it the one where you like get rid of the power?
Get rid of power, like what do you mean get rid of power? Like reduce the power, half angle? I think you talk about that half angle. I think you talk about that. But not yet, because you still have sine, cosine. Make them into just sine or cosine. Just one thing, so you can handle it. Sorry? Yes. Oh, that one you said? I didn't hear that. Using this is the best formula. This is the best formula to convert sine, cosine. Where is it?
All the way up.
This one.
Oh.
Yeah? You can always change sine become cosine using this.
Wait, mister, but those are adding. The ones that we have are multiplying.
Oh, this same thing. Is it multiply? But you still can do it, right? So changing them. But which one you're gonna change? You're gonna change the sine 6 or cosine 4?
Cosine.
If you're using the cosine 6, which power going to be the outside? You know what I mean? Okay, think about this. If you're gonna using this, you're gonna have 1 minus cosine square to the power? No, not 2. This is power 6. 3, right? And if you're using this, it's going to be 1 minus sine square to the power 2. Which one better? The 2 better, right? Right?
Yes.
So change this one better. Change the lower power better. Okay? Okay, so change. Convert. Okay, convert. Convert the lower power.
What was the other one? Square root of what?
All right, so that equal to sine 6. 1 minus
Huh?
sine
Oh.
sine what? Square and square. Very good. Then sine 6.
What?
1.
Yeah.
Yeah.
What
Next.
do you ask?
One
What do you
minus-
ask?
Expand this. 1 minus. Very good. 1 minus 2.
Cosine.
Plus
Okay.
plus sine 4. Very good. Okay. You expand the square. And now you just multiply everything. Right? Multiply everything.
So sine.
Minus 2 sine 8 plus sine. Very good. Yeah?
Now we take the integral. Wait, why is it minus 6?
Huh?
Oh no, that's the dot. Never mind.
And now what?
Integral. Because
Wait,
they're all x
I'm
now.
confused. Mister, I'm confused at this. How do you get
I don't know how to.
Which one?
Integral.
So what's good? Are you still following?
They're
Which one?
all
Which
x.
one?
one in the middle?
The middle here?
Yeah, the in parentheses.
Oh, I expand this square. I expand this.
Numbers are too
A minus b square is a
Oh,
square
yes, yes,
minus
I got it.
2ab plus b square. Yeah?
And then, but from there,
and then I distribute this.
Okay.
Yeah, I just distribute it.
Thank you, Mister.
Uh-huh.
How can we
Any other question? Yeah, do the same thing like this
do we take out
on Friday. Ask me.
Mister, do we take out the 2?
You can take out the 2, but the 2 only stick to this. If you take out the 2, that means everything needs to have 2. So just keep it for there.
So
Keep
we
it.
just do integral.
Just do integral, but how do you do integral though? So now you're gonna have what? You're gonna have integral of sine 6 minus 2 integral of sine 8 plus integral of sine 10.
Because now they're.
I just break them each. You can break them, right? Yeah, easier. But how do you handle this?
Wait.
Is it not the same way we've been doing it?
Yeah.
Oh,
Then what we gonna do?
so
You using what formula you using? Let's tell me the formula that I know and you know it. The half angle formula. Okay. If not, then how do you do that?
I don't know. Sine
Do you
7
think you're gonna using cos Yusuf?
Sine 7.
Can we use Yusuf? Why not? Very good, but why not? Because if you think using the Yusuf, you take a derivative. There's nothing for you to cancel out, right? So you cannot use Yusuf. You need to reduce the power. Okay, so how about update the note here? Update the note here. Odd power, you're gonna use Yusuf. What about not odd power? Okay, let me add up here. Can we add up or we write new one? Which one better for you? Write new one or add up here? Okay, new one. Okay, new one. Note
Yo.
if there is no odd power,
Bro, Joshua just looks like some kid at a boat.
use half angle formula. To reduce the power. Me too.
Draw Emily how you see it.
If there's no odd powers, use half angle formula to reduce power.
I look like the. No, it was not. It was a cute seal.
Okay, sine 6. How do you reduce it?
Wait. Oh, 1.
Okay, 1/2. Very good. 1 sine is negative or plus? Negative. So 1 minus cosine.
Oh yeah, because they're different. Yeah, they're different.
It's still 2x. The power 6. That means everything here is cubed. The inside here is still just x. So you double this. This become 2x. Okay. Oh, actually, don't do 1/2 here. Do half here, because everything here needs to be power. Power 3. 3. Yeah, 3. Because this is power 6. You reduce half of them. Half of them. That's what they call half angle.
Because the 1/2 that you take out.
1/2 because if you write 1/2 on the front, I know that's a chance you forget to keep the 2. So that I put in here, so you know, oh, the 2 will be affected by the cube. So that's why I write like this. So I want you to I want to prevent the chance to make a mistake. Okay, give me the middle one and the third one, and then I let this one for you. Okay, figure out. We need to move on. You know how to do this? Okay, let's write the rest of them first. Again, minus 2 what? Minus 2. Open parenthesis. 1 minus cosine 2x over 2. Everything to the power 4. Half of them. That's what I call half angle. Yeah, half of them. Okay. Yes. The 2 and 2 here, you cannot cancel out. Why we cannot cancel out? Because 2 here affected by the 4, right? You can cancel this out, then it becomes 2 cubed. But then we're gonna take that later. Okay, last ones. 1,
Why am I so
1 minus cosine 2x over 2, everything to the power 5. You got it. You got this.
We're
Okay.
getting 5. That's
Yeah, I
fine.
got that.
And plus C, mister. Oh, wait, no.
You made me fat.
You still have to take integral, no?
Bro,
And then you're gonna take integral. Okay.
Oh, man.
bro, that's what she did. Didn't even put no thought into
Okay,
it.
we're gonna continue this one next because that's a long. I just make it up the problem. That's why. We this is now you just need to expand them and then take the integral of each. It's easy. Just expand them. It's just long. Okay, expand them. For example, cube, you're gonna have 1 minus 3 cosine 2x minus 3 or plus 3 cosine square 2x minus
And
cosine
that's just for one?
cube 2x. Yeah.
Bruh,
Everything 1 over 8.
Oh, man.
So remember the test, they're not gonna ask you to do this.
Okay.
What they will ask you, it will be on multiple,
multiple
choice.
choice.
Okay, they will ask you which method you're gonna use.
Oh,
Yeah, which method you're gonna use? You're gonna use half angle formula to reduce power. They will show you, oh, use sub or integration by part or Trig sub, and then half angle. Then you know how to answer. Okay.
Wait, why 1/8?
1 over 8 because cube, 2 cube,
Oh,
2 cube. Okay, and then this one you can take integral of each, right? And then this one, see, the square is going to be long again. Because square, you need to reduce again. So they're never going to ask you this to do on 3-1 question. They just ask you which method is good. Okay? I make it up. I make it up this one. So that's why it's long. But we're going to stop there. It's easy now. Now, let's go to the second part of the trig sub. I mean, trig integral.
Why am I? I'm not. Yeah, I look. Yeah. I look like.
I didn't know Emily slander was not permitted here.
Very similar. Let me write a note for you.
Have you not heard?
I wasn't invited to the wedding. Is all I hear.
Huh?
Really? I checked.
What? Strategy?
Oh,
What did you say?
we're wearing like.
Huh?
What are they called colors?
Strategy. For this.
Make it like Biggie Chan. With the big chin.
M and N.
It's a turtle.
Oh, man.
Ooh.
Glasses, Mr. Mackey.
I have something to make me look better.
No, it's M and M.
I'm doing the rock face. I'm doing the rock face.
And the computers.
Doing the rock face.
wait, is even save?
Save, yeah. Like break. Okay, separate. You can use the word separate. You have been using the word separate. Let's use separate.
Oh my gosh, you know some
No, that's. Oh no!
Yeah.
I lost my Buddhism way. I lost my Buddhism.
Wait, you're gonna kill me?
My bad. No, but I had
Mhm.
games.
Oh,
What is
man.
Tangy?
Tangy.
Oh shit! We might be failing. We might be. We got to put it in there. I'm used to tan X. That's Parker, after we do pretty good on the lesson, then we start asking, what is tangent? What is the integral of
What is the derivative?
what is the derivative of x? I don't know.
So in this type, secant and tangent, we're gonna use this formula. This formula right here. Okay, secant square minus tangent square is 1. So that means tangent square is secant square minus 1. Or secant square equal to 1 plus tangent square. Okay, just memorize this, you will get this too. Okay.
And then are we gonna have some problems that are like sine over cosine to make that into tangent square?
Yeah. You will have tangent. Yes, we will have that. We will have that.
Like if we have like some like this.
Okay, don't worry. I'm gonna send you this note. Okay. So let's move on. So let me summarize. So when you see this form, tangent and secant, so basically it's just similar to sine cosine, but it's if you change everything to sine cosine. Okay. If the secant power is even, we're gonna save 2 secants. Okay, secant square. You're gonna save them because we're gonna convert them into tangent. Similar to what we did over here, right? You convert all of them into one thing. So if you see secants,
Political news.
if you see the secants and the power is even, you're gonna change that into tangent square. Okay. All right. If the tangent power is odd, what you gonna do?
We separate it.
You're gonna save secant and tangent. Why? Why?
Oh, because we'll still have like a secant, or we'll have a square, and since we break one down, we'll have one odd.
Okay, can we come back here? Can we come back here? Can we come back here? Okay. The reason why is u equal to secant. Du will be equal to, what's the derivative of secant? That's right, secant tangent. That's the reason why we separate the secant and tangent, right? And then we're gonna u sub will be equal to secant. Every time you see the tangent, you're gonna convert back to secant square minus 1. Yeah? Okay. Now next case. I will give you each example. Next case is when there is no secant power, like you don't have any secant. Then you want to use tangent square equal to secant square minus 1.
Like it's just secant.
Like you only have tangent. If you only have tangent, you don't have tangent. Yeah. And then you convert tangent to secant square minus 1. Then you use sub. What is the derivative of tangent? Secant square. Right? Then you will see that we convert everything to secant square. And then you also have the derivative. I'll give you an example for each one. If there's no tangent power and the secant power is odd, you're gonna use integration by part.
You know what I got?
Oh, we couldn't do the trig sub time.
We're about to leave in 2 minutes.
Mr. The Sudoku will be on this.
The Sudoku will be all the problem. Then you need to do it with different method.
So like you sub and like
You sub, integration by part, partial fraction. Which case is this? Which case is this? You have 4 cases, right? Which one is this?
the first one.
All right. Can we focus on here? You only have 10 minutes left. Can we focus on here? I think you all have been over the place now. Okay, which case is this? This is still trig integral. Okay. Case the first one because the secant power is even. Now I'm gonna show you how this works. Okay. Separate x secant square. You're gonna separate them so become tangent 6 secant square and secant square. Why is this? Because think about the derivative of tangent is secant square. Okay. So you're gonna use secant square equal to 1 plus tangent square as a u sub. Not a u sub, but convert everything to secant square. So tangent 6 is okay. Remember, secant square is 1 plus tangent square. Oh, my bad. You convert the secant square. So tangent to keep them the same. But secant square here become okay. And then secant square to keep it because that's going to be the derivative of tangent. Very similar to sine cosine. Okay. So I'm gonna save that. I'm gonna keep that secant square x dx. Now which one I'm gonna let u equal to tangent, then du equal to secant square x dx. You see that happen here? So the whole thing here is actually du. So if you're confident you know this equal to du, you don't need to write dx equal to something. But if you want to be careful, you can write dx equal to du divided by secant square, and secant square they cancel out. Same thing. Okay. So this whole thing here is du. Okay. Now tell me what you write. Tangent 6 become
U6
very good plus 1 plus
U squared
very good and du. Nice. Yeah. The whole thing here is du. So now is that easy then? You're done. You're basically done, right? So you have u6 plus u12
U8
u8. Very good. And then that's become u7 over 7 plus u9 over 9 plus c, right? Plug it in back, you have tangent x to the power 7 plus tangent 9 over 9 plus c. Yeah? Very similar to the sine cosine though. Okay, homework then.
Mister.
We're not gonna touch the trick stuff. So we're gonna do homework then.
Homework.
Yeah.
Mister, can you send it to us?
Right. I will. I just upload all the video. And the note I'm gonna send it today. Yeah. Okay. 9, 10. Okay. 10. Huh? I don't know. Just do the homework. Whenever I give you homework, do the homework. Okay.